Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with IgniteNet and EdgeCore. Today's host is Dan Kazwara, and he is their application engineer, and he will be presenting today. If anyone has any questions, please submit them in the question box, and Dan will answer them at the end of today's presentation. Dan, thank you so much for being with Microcom today. We greatly appreciate it. I am finished for now. Please go ahead and take it on over.
All right, great. Thanks, Julie, for having me today. And thank you, everybody, for taking time out of your day to attend today's webinar. Okay, so today I'm going to cover, now, if you notice here, IgniteNet and EdgeCore, people ask first, who's EdgeCore, if you're familiar with IgniteNet. EdgeCore actually owns IgniteNet. They're actually one of the same. So today I'm going to be covering both IgniteNet products and EdgeCore products, and the Wi-Fi best practice as an EC Cloud. EC Cloud actually can manage both the EdgeCore and IgniteNet products. Okay, so first, I'll be first talking about the indoor and outdoor access points, both with IgniteNet and EdgeCore. Okay, so let's get started with that. Okay, so you may be familiar under the IgniteNet product line, there's the Spark AC1200, if you guys are familiar already. That's Wi-Fi 5, and you'll see that some of the newer stuff, IgniteNet, we don't have any Wi-Fi 6 IgniteNet stuff. That's all going to be under the EdgeCore name going forward. So if you're looking for Wi-Fi 6, that'll be under the EdgeCore. I'll cover that soon. So the Spark AC1200, it's been around for a while, and one of the things that this guy is still being sold, and it's still pretty popular. And one of the takeaways I want you to get from this AP is indoor and outdoor. It's not officially IP rated, but it's around like an IP55. So for the price point it is, and what you get for an indoor and outdoor AP, I mean, it's a great product for that. Now people are thinking, oh, it's Wi-Fi 5, it's so old and outdated. Well, let's compare. We're talking about 802.11 AC, Wave 2. You know, 2 years ago or 3 years ago, that was the latest, greatest thing, or let's say a few years prior. Right now, it's old. Well, I compare that to, like, let's say, you know, the iPhone 15 just came out. And, you know, when the iPhone 12 or 13 came out, it was amazing. And now you're being told it's just outdated and it's old. The truth is Wi-Fi 5 or AC is still very good. And in most networks and most applications, that's all you need. Now, more demanding networks, more performance is required, or if budget is a major concern, then certainly go with the newer stuff. But if budget and cost is a big factor, this is one way to get very close to the same performance, but with a much lower price point. So that's the strength of the Wi-Fi 5 products. Here's the AC2600. This is the 4x4 version of the basically the IgniteNet stuff here, where it's outdoor also, but it's 4x4. It has more processing power. And also it has 4 radio chains, so it's a 2600 model. There's the 2 minis. If you're familiar, the Wave 2 minis are cool. They're really small. There's 2 variants of it. There's the mini, which is powered via USB, 5 volts, 1 amp, basically 110 volts plugging in the wall, and the other was PoE. PoE only. Those are the 2 differences. But you look at the size of these, they're like 3.3 inch by about 1 inch, really small. They're really popular in MDU spaces, and just where, you know, say like less coverage is required. Let's say like a dorm room, or just like 1 room coverage, or a smaller apartment. And again, if you look at the price points, these are very aggressively priced. Here's a quick overview. All right, now let's move on to the EdgeCore. Now the EdgeCore product line, now we're talking about Wi-Fi 6. And what do you get the difference between Wi-Fi 6 over the Wi-Fi 5, aside from it being 802.11ax? You'll see that there is the modes before. I'll go back here. The modes you can do is, if I can get it here, AP and bridge mode. Okay, so you could have an access point, or you could bridge it. Where the Wi-Fi 6 stuff, you could do mesh also. So mesh is available on all the EdgeCore Wi-Fi 6 products. So you could do AP mode, mesh, or bridge. The EAP 101 is similar to the Spark 1200, but it's really just indoor only. One advantage of this one is it's AF. You only require AF power, the 15.4 watt, the lower PoE power to power these, which is kind of good. So if you have an older switch and you want to still power it with lower power PoE, this guy will run off that. The AP102 is the 4x4 equivalent. So it does require AT power. So that's, it does require a 30 watt PoE to power it. Both of these actually have 2.5 gig ETH ports, uplink ports, which is probably on this one's a little overkill, but the 102 arguably could potentially use it. But so it's 2.5 gig ETH uplink ports. There's secondary ports on these as well. They're not PoE pass-through, but okay, so the EP, this one also is supports mesh. Like I said, all the Wi-Fi 6 stuff supports mesh. All right, the EP104. This is an indoor wall plate. So this is cool. This is popular in the MDU space also, where you can see that it has a couple LAN ports, like a small switch built in. It also has PoE pass-through. So on one of the ports, if you power it with AT in, it'll be AF out on one of the ports. So that's kind of cool. There's another variant of this called the EAP104 Lite, which is a little bit lower cost, but it removes the BLE and no PoE pass-through. Figure in a lot of these applications, installations, you got several hundred being installed. So of course, even the cost per unit, even a small difference is going to make a big difference, especially if you don't need those two features. Another thing I didn't mention here, the APs so far can be all standalone. They could be EC Cloud managed, or you can get it, and it's a different part number. I want to point this out. People are interested in the tip open Wi-Fi versions of these. You have to get the correct part number. The AP, in this case 104, it's T, anything with a T. You have to make sure if you're getting that variant, make sure it's kind of you can load the firmware and convert it, but it's kind of difficult. So really make sure you get the right one. So if you're getting open Wi-Fi, that's a different part number. Coming in the future, it's the EP111. This is an indoor outdoor. This is kind of the really truly replace, say, the Spark 1200. Eventually those will be depreciated, but they're still going strong. People are still buying the AC 1200, pretty popular, like I said, mainly because of the price point, and it's an indoor outdoor AP. This one will be IP55, so it really will be the indoor outdoor equivalent. And the ETA for this is December. Okay, and this beast I want to mention now. Also, EdgeCore has other APs. I'm not covering all of them. There are some other outdoor APs that are Wi-Fi 6 or even Wi-Fi 5. There's some older outdoor AP, IP68 rated APs. I'm not covering them all today. This one's interesting. It's coming out soon. This OAP 101.6E. So this is IP68 tri-radio. It's 3 radios, a 2.4, 5, and 6 gigahertz. Yes, Wi-Fi 6E. Where's 6E? There it is. It's coming out soon here. All antennas have a negative 20 degree down tilt, which is pretty cool. It's got 3 radios, but they're 2x2. You can power it with just AT power, which is pretty neat. And I said IP68 rated, so look out for that one. And people ask, Wi-Fi 7, where's that? Okay, it's coming soon. I can't give any big, great details, but there is works of getting a 2x2 and a 4x4 coming out in Q1 or so, and should samples be available in Q1. So if you're wanting more information on that, certainly reach out to us. Okay, next I'm going to cover the cloud. So the cloud, okay, I think first thing I want to point out with the cloud is that it's free. So you can create an account. You just go to cloud.ignitenet.com and create an account. If you want to play around with it and go on there and see what it's all about, how the GUI is, how it works, you don't even need a device to see that. You can create the account. Now, previously, a lot of people don't know, before it used to be just 2 devices and then you'd have to get the paid version. But actually, it's been a few years now. It's been upgraded to where you can now have up to 50 devices for free. And then if you have more than 50, you want to manage more than 50, the cost is just $99 per year. Okay, so EC Cloud actually controls a lot of things or manages lots of things, not just IgniteNet stuff. or access points, it actually can manage the indoor and outdoor IgniteNet APs, switches that IgniteNet has. Those are pretty much EOL at this point, but there were 8-port and 24-port switches. Then there's the 60 gigahertz. That's the Metrolink product line. You're probably the most familiar with IgniteNet is the 60 gigahertz Metrolink product line. Manages those. But also the EdgeCore products, the EdgeCore APs, the EdgeCore switches, and the Teragraph 60 gigahertz EdgeCore products. You see a long list of supported devices there on the display on the right side there. That's actually not all of them. There's a few more since this list that has been added as the product list. You know, as more products get made, more gets added to this list. Okay, now quickly going over the cloud here, the cloud dashboard. So your cloud dashboard, that's like your main overview. And there's tiers. You got your main cloud, you got your sites. That's basically like your locations or groups. And then you got your devices. So I'll go over that real quick here. So you got your site level. So that would be like a location. That could be a customer site, or it could be a building, could even be a floor. And then as you dig down further, you got the individual device. And what's nice about the EC Cloud is that you could see all the devices connected, you know, remotely looking in at that AP, what's connected, you know, the signal strengths of those devices, those client devices connected. Quickly see if there's any issues for troubleshooting, such as signal strength is one dead giveaway. Of course, if you got a poor signal strength, you could troubleshoot that. Now I'll cover that a little bit here in a second here. I'll go in more detail. Another thing on EC Cloud really cool is you could set up an email address and set alerts. You can set the time it takes before the alert warns you, so you don't get too many, let's say, false alerts. Like you wouldn't want to set if something goes down for 1 minute, let's say. But if it's down for 10 minutes, you can set that. The device is unreachable. Device rebooted. There's a whole bunch of different email notifications you could set. It's kind of nice. You can get notification before even say that customer calls you. You could be right on it. Okay, other features I want to and I'm just going to kind of go over some of the things in the EC Cloud that are really cool features. One of the cool features is the live status at the access point. When you go to the access points dashboard on EC Cloud, you can look at channel utilization. This is great for troubleshooting. And it's generally accepted in the Wi-Fi industry that if you have 40% or higher channel utilization, you're gonna start seeing degraded performance. It's just kind of, now, live status meaning of just a peak of like 90% because you know there was a high demand, but I'm talking about an average number. So you could see here what's going on kind of more real time here with the live status, like channel utilization, radio utilization. I want to point out, people ask this often, what is the difference between channel utilization and radio utilization? So radio utilization is the actual access points radio, how often it's being used as a percentage of time, and then versus the channel it's on. So in this case, it's on channel 149, it's 9% channel utilization, 1% radio utilization. That means out of that 9%, 1% is coming from this AP, 8% is from other APs within range, and it's picking up on the same channel. So those are the two things. So radio utilization is always less or equal than channel utilization. What's more important for troubleshooting, I would say, is channel utilization history, like the average. In this example, see here on the right, utilization has at worst been up to about, I don't know, a little below 15% if you look at the chart. So that's really good. But if I'm seeing averages 40, 50, 60%, then I could see maybe I got a channel issue. I got co-channel interference, might have adjacent channel interference. I don't know, you know, something's going on. Maybe I have too many clients on one access point, or I have too many slow clients. You know, in other words, like this is a good tool to start seeing what's going on. And you know, if you're starting to see or getting complaints of performance issues on your network, channel utilization is one of the first things to look at. And it's nice to say you could remotely look in from EC Cloud. You could have an AP, you know, hundreds of miles away. You could easily manage and look at that. It's kind of nice. Another thing you can do on the cloud here is to do just a basic Wi-Fi scan, you know, scanning like you would and just see what that AP is seeing. In this case, I did a scan and I'm seeing here on channel 157 a signal strength of -15 dBm. That's actually my home router. So obviously I wouldn't want to use channel 157, but it's also good for troubleshooting, or also to help for me to choose which channels. Maybe I want to limit the range of auto channels to pick from, or maybe just set it to a fixed channel based on what I'm seeing here in this Wi-Fi scan feature. The nice part is you could be remote somewhere else, far away. Figure the person there on site, your customer may not know anything about Wi-Fi. You're far away. You can do some of the troubleshooting, a lot of the troubleshooting remotely using these tools built into the EC Cloud. Another cool feature, this is actually pretty new. So if you guys, you guys here are already users of EC Cloud and already working with our stuff, and you may not be aware there is the speed test feature. It's been recently added, which is really cool. What I like about this feature is that, okay, so figure you're trying to isolate the issue, right? You got your client, your wireless client device complaining of poor performance, or the users. You're not sure, is this a ISP issue? Is this an Ethernet issue? Is this something, or is this a wireless issue, or is this a wired issue? Well, how about, start doing a speed test at the AP. What is the AP seeing on the wired side going out the ISP? So you can see you can do a speed test here and you can see what's going on there. At least start there. And then you can see, you can isolate whether or not it's a wireless issue or a wired issue. This is a cool, I really like this feature. We finally added it. I've been really pushing for this feature. Another thing you can do on EC Cloud is the client statistics. So clients on the AP live status. Now I showed it earlier, but an individual AP has a bunch of clients connected, right? And you scan, you can see them all. You can see the signal strength, how they're connected, how strong they are. So there's like a list here of, they're all connected on either the 2.4 or the 5 gigahertz band. You could sort that way. You could sort also by, the signal strength. What I like to do is actually for troubleshooting, sort by signal strength in reverse, seeing the weakest first. If I see some clients connected while they're online at like say -80s, really bad, -88, something really, really poor, I know there's a problem there. There's most likely. Now, is it because they're outside in the parking lot and it doesn't matter, or are they complaining they got poor Wi-Fi performance? And if they're complaining they got poor Wi-Fi performance, then I got to look at why the signal strength is so weak. Is pretty much is there a coverage issue? Is there a problem? Or did I got multiple APs and I got one. Sometimes people don't realize that some client devices don't work on DFS channels, and you got a DFS channel, and then you effectively have a coverage hole. This is something like 5 gigahertz. There's some weird stuff, but you can learn a lot by just looking at signal strength. Here's now the live and historical data of a client. This is an individual client you can do. This is on EC Cloud. This is my example, is my home where I have my water sprinkler controller, and it's connected. You can see the signal strength history, which is kind of nice. It's been pretty stable. Not the greatest signal, but it doesn't need to be. It's just a controller. It doesn't have a lot of bandwidth requirements. And I can see which AP it was connected to. But figure another client could be mobile and roaming from one AP to another. You'll see the signal strength go up and down as they move, and even change APs. And you could look at the history of which APs they connected to as they roam from one AP to another, and see the client history. Another thing is the live data portion here, which is really cool, because then you could see what MCS or data rate they're connected to. Not only signal strength, not only dB of SNR, but actual data rate download and upload. And you see it's asymmetrical. In other words, it's not always, typically, you're not going to be exactly the same, and depending on, interference and signal strength. So that's kind of helpful for troubleshooting. I'd be normally concerned I'm connected to down, a rate that's kind of low, but it's a sprinkler. It doesn't matter if it doesn't, connect and, talk to the network, the internet, and get, let's say, updated information that quickly. It's not that important. But for say more demanding devices, this would be a good, definitely a first thing to look at on an individual client basis to do some troubleshooting to figure out what's going on. Okay, and I mentioned Wi-Fi best practices. I want to do this because I get these are kind of the top. There's a lot of things that come in, but I get the same troubleshooting things here. Is I get people asking and trying to troubleshoot networks and problems, and I see the same things happening a lot of times. So I want to kind of cover the top 10 that I've seen and ways so I figured I'll just do 10. There's more, but the thing I see the most of to, things that should be done to fix things, or what I do right away to fix things, these are the top 10. Okay, so the first one, of course, I think is the most common and I think our controller does default to channel 40. I think we're not the only manufacturer that defaults to a 40 megahertz RF bandwidth setting on 2.4 gigahertz. So, and I think it's kind of typical because you want to see best theoretical performance and connection speed looks better and all this stuff, but you definitely want to set it to 20 megahertz. And another thing is you only want to set 2.4 gigahertz to channels 1, 6, and 11. So out of the box, it's auto channel and it's 40 megahertz. So you need to change it to 20 megahertz and you need to set it to 1, 6, and 11. And I did a separate slide just on this alone because it's so common. It's such an issue. So the reason why is because it doesn't make any sense when they did the 2.4 gigahertz band. I don't know what they were thinking because they got the 5 gigahertz band right. It turns out each channel spacing is only 5 megahertz. But the problem is, unlike on 5 gigahertz where they didn't allow the user, you can't as a user set your AP to use channel 37, let's say. Yeah, in other words, you set it to channel 36 and then it forces you to go to channel 40. You can't use the in-between channels. So therefore you can't set a channel that's in between the channels and then interfere on itself. But on 2.4 you can. So unlike pretty much all other radio RF out there, I mean, if you look at like a CB radio, it's a 10 kilohertz spacing between the channels, and then the channel width of AM is 6 kilohertz. So no matter what, you're never wider than the transmitted. The transmitted signal is never wider than the channel is, so you never bleed into the next channel. This is dumb, but that's the way they did it. So the only way to avoid it is actually go 5 channels away from the next channel. And this is like you see in the example. So it's really just channels 1, 6, and 11. If I were, the powers that be, I would make it to where users can't select in between 2 and through 5. You can only set channels 1, 6, and 11. You can't change it. But one thing I recommend is go into the auto channel settings in our cloud and set it to 1, 6, and 11 only as the selectable auto channel options for the controller to use. Those are the only channels that are available, 1, 6, 11. Okay, other things to do, in multiple AP deployments, maximum RF output power not to exceed 17 dBm. Okay, if you just have one AP, you could crank up the power. Sure, it doesn't really matter. I mean, that's the only coverage you got anyway. It's just one access point. And I guess, without thinking about other neighbors and things, but I'm just thinking about one access point. Arguably, power is less of a factor. But the biggest issue I see, and this goes along with even number 4 here, the problem is when you have multiple APs, you need to encourage proper roaming of the client devices. And if you turn up the power too high on either band, but especially 2.4 gigahertz, the client device will not roam. The device needs a signal strength to drop below a certain point, get below, let's say, negative 70 dBm or weaker, to even start to scan to look for the next AP to roam to. And if you crank up the power too high, that's when you get what they call the sticky client issue. It hangs on to the wrong AP. You could be under the next AP and yet not roam, is because the previous AP is still got a negative 68 signal because it's blasting, so you're not roaming. So that's a big problem. I see that all the time. And some of our APs go up, 24, 25, 26 dBm. So it's really high. So, and out of the box, they're even kind of high. So that's one thing I recommend doing, is turn down the power for those kind of issues. The other thing is make asymmetrical power between the 2.4 and 5 gigahertz. 5 gigahertz propagates much less. There's the free space path loss difference between 2.4 and 5 gigahertz is about 6 to 7 dB alone. Add that on top of the fact that 5 gigahertz doesn't penetrate walls as good. You could add another even 2-3 dB on top of that. So we're talking potentially up to even like a 10 dB difference. So how do you deal with that? What you do is you make the power setting on your 2.4 much lower than the 5. In this example, I said about 10 dBm on 2.4 and 17 dBm on 5. That difference kind of matches the coverage cells. And you think, that's so low, that power so low. Well, people don't realize that client devices like iPhones and they're putting out around 10 dBm. They're low power. So the fact that you got one really loud, the other one really quiet, it doesn't, you're already mismatched in power as it is already. So um, that's just another thing that I think people overlook, is that these client devices are really low power. So yeah, that's a big one too. And to go along with that, sometimes you have what they call, and this goes on number 5 here, inter-AP roaming. So inter-AP roaming is where the problem is when you got the power the same. Let's say you have a set to 20 dBm on both 2.4 and 5 gigahertz. Well, that means the 2.4 gigahertz signal is about 7 to 10 dB stronger, even though the power is set to the same. Remember, 2.4 propagates better. Well, the client device might see the same AP and then get out of range of the 5 gigahertz signal and then roam to the same AP's 2.4 gigahertz radio. So it's kind of a weird issue, but that can happen. So another thing to do is just set 2 separate SSIDs, one for the 2.4 band and one for the 5. So call it, guest network 2.4, guest network 5 gigahertz. It'll completely rule out any inter-AP roaming. Also, I like to separate the bands for a second reason, is that, if you have 5 gigahertz capable devices, you keep them on 5 gigahertz, you could then select it. Where 2.4, they won't need to see the 5 gigahertz SSID, leave them on 2.4. 2.4 is pretty much performance is given that it's going to be worse. Generally speaking, IoT devices that are 2.4 generally don't need the performance. We're talking like controllers and things that, generally speaking, they don't need as much bandwidth. So it kind of works out. But anyway, that's the kind of things I've seen that I recommend doing. Another thing I see is the number 7. One of our settings on our AP is route to internet versus bridge to internet. So basically, route to internet means, okay, this AP is going to act as a DHCP local server, going to hand out IP addresses. But the problem is, if you have multiple APs, then you can't roam. You can't do a seamless roam, because then you're breaking the IP session. You're going to lose your IP address. You're going to go from one AP to the next, and then you're going to disconnect. You could do a nomadic roam. You could disconnect and reconnect. But if you want seamless roaming, you got to have bridge to internet, and then your routing has to be done behind all these APs. And the same goes with even captive portals. Captive portal is a single session on a single AP session. So if you break, you go to another AP, you're going to lose that too. So just keep that in mind. That's a common one I see as well. Also, there's the number 8. You got 2.4. Let's say you had a hotel with like 20 access points. 2.4 propagates so good. Even if you turn down the power 7, 10 dB weaker than 5, it goes through everything so much better. It goes through ceilings and walls that you may need. A common one is to maybe disable 2.4 on every 4th access point, or just, or go in there and kind of look and do the Wi-Fi scan and look at your own interference and see you may not need 2.4. You could see when there's a disproportionate amount of client devices connected on 2.4 that are 5 gigahertz capable. That's kind of sometimes a sign that you got too much 2.4 gigahertz coverage. Another one is, I've seen this where, let's say you got a hotel and you got your access point. Figure 2.4 is going to propagate way out in the parking lot a lot further. So somebody who's a regular, or maybe a building, an office building, you'll start associating to the 2.4 out in the car, because then the 2.4 is going so much further. Then by the time you get in, now you're on 2.4. You don't need, you connected on 2.4. I guess that goes back to the original thing of my my suggestion of setting separate SSIDs for 2.4 and 5 as well. So so that's a common one too, is that, you come back into the property, and then you come from the car and you come in and you're connected on the signal strength the signal that's only seen at first is 2.4, just propagates so much further. Okay, number 9 is 40 megahertz for 5 gigahertz. Okay, I mean, default 80, you can set it to 80, like for home, if you want to, maximum throughput. But generally speaking, here's the thing, many ISPs, you're not even seeing what 80 megahertz could provide anyways. If you got 100 megabits or something, you're never even going to see. Many times I've found that setting it to 20 or 40 megahertz, actually, it does result in a much more reliable and stable network. And there's less interference from other stations, and also potentially yourself in a multiple AP deployment. that in the end of the day, you might see higher peak speeds, like impress, customers wanting to see a high number on the connection. Yeah, the 80 looks good, but if you want a really stable, reliable network, actually narrower channels is the way to go. And many times you're not even exceeding what the network's going to do anyways. So that's a common one. And manually, so number 10 is setting channels manually. So don't be afraid to go in there, manually override auto channel settings, and if needed, disable 2.4 or say 5 gigahertz, use a specific channel. One cool channel a lot of people overlook is 20 megahertz channel 165 on 5 gigahertz, right? In a pinch, when you got some interference, or even on 5 gigahertz, a lot of times that channel 165 is not being used. So, okay, and that concludes my presentation. I'll pass it over to you, Julie, if there's any questions.
Hi, Dan. Thank you so much for that presentation. Enjoyed it very much. And yes, of course, I've got questions for you. Let's go ahead and get started with the first one. Let's see, here we go. How does EC Cloud integrate with IgniteNet and EdgeCore products?
Well, I think I covered that. The thing is that it handles both. I mean, I say it doesn't really integrate. I mean, it supports, a better way of saying it, it supports both product lines. So most of the EdgeCore APs are now added into the EC Cloud. Before, originally IgniteNet, it was just IgniteNet products. Then a few EdgeCore here and there, and now there you can see the list that I had for a few slides back, a huge list, and then a lot more EdgeCore switches. So yeah, they're pretty much supporting there, and they're not really going back to the really old products, especially like the EOL products. But anything going forward, of course, it's all supported, and like those new models coming out, they're all going to be supported on EC Cloud. So yeah.
Thank you for that, Dan, for touching on that again for us. Jumping into the next question. What analytics and reporting tools are available to help businesses make data-driven decisions?
Well, there is, okay, so in the EC Cloud, there's statistical data of a day, week, and month. I'm not sure if I'm exactly answering that question. So, I mean, it's in other words, a broad question, but as far as decisions go, but you could look at historical data. I'm not sure if that's the question. I'm a little bit lost on that exactly, but yeah, I mean, statistical information is recorded up to 30 days of the stuff that was in there, and you could use that to make decisions based on like performance and what you're seeing, and make adjustments as needed.
No, that's good. Thank you, Dan. Appreciate it. No problem there. Let's see. Here we go. Next question. What kind of warranties and hardware replacement policies do you offer?
Okay, yeah, the EdgeCore product line has a 3-year warranty. And you just reach out to support, as you see the email there, support@edge-core.com. And or if you're inquiring about, say, like if you're inquiring about new products, people have questions about Wi-Fi 7, sales@edge-core. Also, I kind of wanted to mention, I didn't mention it yet, if you want a demo or showing EC Cloud, or even if you're an existing customer and you want us to go over the EC Cloud with you and show you the highlights and some tricks and things, and for the EC Cloud, we're happy to do that. You can reach out to support, drop us an email, and we could set up a time where we could spend a little bit of time with you on it.
Excellent. Thank you, Dan, because that is a common question. People like to know if they can, talk to someone there at IgniteNet and EdgeCore and see exactly what they need. And I know you guys have excellent help and support and all of that. So would we then, or if anyone wants to do that, I know you're showing your contact information. They could probably find it on your website. Is that where one would get started?
Yeah, you could check, EdgeCore, edge-core.com. You could see the products and things. But yeah, as far as, getting actual, like reaching out to getting one of us or either on the support side or sales side, work with you, yeah, just drop us an email is the easiest way to reach us.
Excellent, thank you. Next question here for you. Let's see. How do you handle firmware updates and patches to ensure network security?
Yeah, so what's nice about the EC Cloud is, yeah, you could look at your device page and all the devices are listed there. I don't have a screenshot of that on this presentation, but if you go there, let's say you have 20 products in there, different models and different versions, it'll show which ones. You'll see an arrow up, very clearly arrow up. There is a new firmware available, and if you want to do it, and you could push the firmware upgrades to one device, a group, in other words, the whole site, or several devices. And then you could also decide when to schedule that. Like, in other words, you could decide to do it in real time, or you could set it for a certain time, like later in the night time or something to do that. So firmware upgrades really nice to do from EC Cloud. One of the big benefits of, say, having that versus like standalone, when you have standalone APs that aren't cloud managed, it becomes, that's where it becomes problematic. I mean, you don't get all these benefits I talked about, when they're standalone. Some people like doing standalone, or they're managing stuff on their own, or just here and there, a couple APs here and there. But that's one of the big advantages of EC Cloud is, yeah, like doing firmware upgrades. That's one right there. Good question.
Thank you so much. Next question here. What security measures are in place to protect Wi-Fi networks powered by IgniteNet and EdgeCore?
I don't know the details, I'll be honest, of that offhand. I know it's secure. We haven't had any issues, like as far as the communication between our cloud and the APs themselves. I haven't heard of any security breaches or anything like that, but sorry, I don't know the details offhand of how that's secured.
No problem. Good to know. Thank you. Next question, couple more, of course, here. Can the devices all be in different locations, or is it 50 devices per site on the eCloud?
Okay, yeah, so the free version, it's 50 devices anywhere. So you could have 50 devices anywhere on Earth. As far as the limitation, as far as the free version, it doesn't matter where they're located. So, and then if you have more than 50, you just, and then there's not really any hard limit. Arguably, we say there's 500 devices per site, and you could have up to 500 sites. So in theory, there's a 250,000 device limit if you get the paid version. And if you do the free version, it's up to 50. Anywhere, in either case, anywhere. They could be anywhere.
Excellent. Thank you so much. Next question. Are the access points indoor and outdoor rated?
Yeah, so some are indoor only, as I covered the EAP 101 and EAP 102 and EAP 104. Those are all indoor onlys. The EAP 111, the Spark AC 1200, and Spark or Sunspot 2600, those are actually outdoor. They're IP55 outdoor. And then that OAP 101, and there's some other ones that are like very rugged IP68 outdoor rated. Like I said, I didn't mention all the APs today. Check out EdgeCore at the website there. You can check out products there. There are other outdoor APs available as well if you're interested in checking out more of the outdoor stuff. I did cover most of the indoor stuff. There are even some other indoor stuff under EdgeCore as well.
Excellent. Thank you for that, Dan. Last question here for you. Can we turn down the 2.4 radios instead of completely disabling them?
Yeah, you can. I forget the setting. I think you can go as low as 3 dBm. I think that's the lowest you can go on the settings for power. I don't know if, the thing is with Wi-Fi, get all technical, but there's this thing where it's a polite protocol. So you got channels 1, 6, and 11. And let's say you got the 4th access point on channel 1 again. It just needs a signal strength of around just above the noise floor, around negative 87 dBm. So believe it or not, even a 3 dBm setting, you're thinking you're doing good by turning it all the way down. Well, it just takes that 1 access point from that fourth access point on the same channel to hear that even 3 dBm signal at -87, to then take turns with it to say, okay, it's not, I'm gonna wait, I'm gonna be polite, I see the channel's in use, channel utilization's in use, I'm gonna wait, I'm gonna take my turn. So arguably, you're still probably better off with disabling the channels. Now, I guess if they're all turned down, I suppose, I mean, I don't know, you know, in practice, I've seen with most of the Wi-Fi designs, people don't do that. And I'll say more details of why, but generally speaking, you don't go super low power. But yeah, I guess you could. I mean, it's just, that would be kind of a trial and error thing. It depends. You know, the thing is like every environment's different. I mean, like say a building, the attenuation between the walls is different. Everything's always different. So to say there's not one size fits all. So maybe that would work excellent in one scenario where another one it wouldn't. So the old saying is, it depends.
Thank you, Dan, so much for answering all of those questions for us today. And thank you to everyone attending our webinar. And if anyone has any further questions, of course, please feel free to contact your sales rep or email us at sales@microcomtech.com. And if you wish to view any of the products mentioned or shown here today, please make sure to know that this webinar has been recorded, so it will be updated to our Microcom YouTube channel, and you can view it all again and listen to all of Dan's very informative information about everything today from IgniteNet and EdgeCore. Dan, again, thank you so much for spending time with Microcom today. We greatly appreciate it and appreciate everyone's attendance. Everyone, have a fantastic day.